We're going to do chapter 4, section 1, number 61. We have this function, x cubed, e to the minus x, and our domains from -1 to 5 on a closed interval. So we want the critical points. So we need to take the derivative, but this is going to be a product rule. So we leave the first alone, take the derivative of the second. That's not an x, so therefore it's box and it's chain rule. I am my own grandpa times the derivative of box plus the derivative of first and leave the second alone. And now notice I have common things. They both have x's and they both have e to the minus x. So I'm going to take out x squared and e to the minus x. In the first one, I'm going to be left with 1x, but it's negative because there's a negative there. And the second one, I'm going to be left with a 3, and that's it. And I want to set that equal to 0 to get my critical points. Well, I set the first one equal to 0, the second one equal to 0, and the third one equal to 0. And I get 0, and I get 3. Here's the tricky part. You have to know when that equals 0. You have to know what that graph looks like. You have to know e to the x looks like this, right? And if you put a minus in front there, it just flips it. So you must know e to any power never equals 0 because the e function never crosses the x-axis. Never, ever, ever. Therefore, this is never true. So you only have 2 critical points, 0 and 3. And then you have 2 endpoints, -1 and 5. And it's asking, I believe, 61 for the absolute minimum and maximum. So important concept. If you have a continuous function on a closed interval, max and mins only occur at critical points and endpoints. So how do you find the max and min? You have to find the y value at the endpoints and the critical points. So that's going to be at -1 and 5 and 0 and 3. So you would literally plug these values into this equation here and find 4 y values. And because max and mins can only occur at one of these 4 points, the largest value will be your maximum and the smallest value will be your minimum.
So when you plug in -1, you will get minus e. Now remember, we're plugging it into the original function. Maybe I should copy and paste this so you can see what's going on. So we're plugging -1 here, which is -1. That becomes +1. So it's negative e to the first. 0, I think that's pretty easy. When we plug in 0, we get 0. When you plug in 3, that's going to be 27 e to -3, which is 27 over e cubed. And the last one, when we plug in 5, that's going to be a pretty big number. Well, I'll just do the decimal approximation, make it easier. So when you plug that in, you get about, do a squiggly about 0.8422. This one, so we can compare, is about 1.344. And that's about -2.714. So the maximum value, what's the absolute maximum? It's going to be the biggest number here, so I'll do it in blue. The maximum value is 1.344 approximately, and it occurs at 3. And the minimum is going to be -2.714 approximately, or -e exactly, and it occurs at -1. And that's that problem.